Okay, this second half of your packet is on reflections. So reflection is a flip over a line called the line of reflection. Each point and its image are the same distance from the line of reflection. And a reflection is also an example of rigid motions, So rigid motion again means it's not changing size. So if I take my fist, for instance, and I just move it over or down, it's still the exact same size. If I take my fist and I flip it, it's still the exact same size. If I take my fist and turn it, same size. So reflections, translations, and rotations are all rigid motion. And a reflection is just a flip across a particular line. So in this case, this would be our line of reflection because it's essentially a mirror image on either side. The points are the same distance from the line of reflection, so B is 1, 2, 3 units to the left of the line of reflection, so B prime is 1, 2, 3 units to the right of the line of reflection. So some of our common lines of reflection, we can flip something across any line, but the ones that we see most commonly in the class are the x-axis and the y-axis. And then from our last unit, we could also flip it across a vertical line, which is in the form x equals a number, and the horizontal form, which is an equation of the line, which is y equals a number. So recall our x equals a numbers, you would go to that number on the x-axis, so maybe x equals 4, might be here, and then I would draw a vertical line through 4, and I can flip it across that. So I'll show an example of that in the examples below. Or we can flip it across the diagonal lines, so example y equals x or y equals negative x. So on the first one, we want to graph and label each figure and its image under reflection given by the line, give the coordinates of the image. So we're taking our triangle ABC, these are the points, flipping it across the x-axis. So I'm going to do that on a separate sheet. Feel free to pause the video and graph these, and then you can fast forward it to where mine are already graphed, so that you don't have to watch me laboriously going through this part. Okay, so again, I'm counting by twos because it's much quicker than writing every single one of these numbers. But I'm still skipping every unit, so this is still 2 units away from the origin. I'm not counting by twos and only using 1 as a half unit. It's actually still a full unit. Anyway, negative 4, 2 is A, 4, 7, 5, 1. Okay, so we want to take this and we want to flip this triangle across the x-axis. X-axis I'm choosing because that's what the problem gave me to flip it across, so I'm going to draw the triangle in. Even though I'm drawing the triangle, you're really only flipping each point, so you don't actually have to draw the figure, but at the end, you can kind of tell if you did it correctly if you drew the whole figure. If there's a bunch of random points, you're not necessarily going to be able to tell that you flipped it correctly. Okay, so right now my line of reflection for this problem is the x-axis. So this is my line of reflection, the blue line. So I want to figure out from the line of reflection to A, it's 2 units. So that means I need to go 2 units, but I go in the opposite direction. So A prime is going to land me here. So that, the line of reflection is the perpendicular, so it's meeting it at 90 degrees, bisector, it's cutting it in half. There's 2 of the units here, 2 of the units here, of the segment connecting A and its image, A prime. All that's fancy for is basically got to be the same distance on this other side. Okay, 1 unit away for C, so we go 1 unit away and put C prime. And then B, even though it's overlapped in this triangle, I'm just going to go straight up to B, and then I have to go straight down to B prime. So it's 7 units up, so I'm going to go 7 units down. And B prime will be here. So when I graph it, You just need a straight edge to graph it. You can use your ID, or there should be a container with rulers in the back. It looks like it flipped across the x-axis, so that's the image, and that's the pre-image. So we're writing the coordinates of the image. So -4, -2, 5, -1. And 4, -7. Okay. If you're flipping it across the y-axis, you do the exact same thing, but instead of counting up and down, since the y-axis is already a vertical line, you're counting left and right. So I'll show that one as well, so you can pause it, graph it. Okay, so this one is a rectangle, so we have 4 points. So P is at 1, 2. Q is at 2, 5. R is at 8, 3. And S is at 7, 0. And we're going to be reflecting this across the y-axis this time. So we'll do X example, Y example, and then we'll do X-axis, Y-axis, and then we'll do a vertical line that's not the X or not the Y-axis, and the horizontal line that's not. Okay, so that was a lot. So Y-axis is where we're flipping it across. So this is our line of reflection this time. So we would, for every single point, we want to count how far away it is from the line of reflection, and mirror that on the other side. So starting at Q, Q is straight over 1, 2 units to the right of the line of reflection. So I have to go 1, 2 units to the left of the line of reflection and plot Q prime. P is 1 unit to the right of the line of reflection. So I'd take 1 unit to the left of the line of reflection and plot P prime. It doesn't matter where I put this letter P, the label, it just matters that the point is 1 unit away. Okay, so 7 units away, so I'd go 7 units away here. And you should start noticing some patterns. If you flip it across the y-axis, what happens? If you flip it across the x-axis, what happens to each of the coordinates? So R is 8, 3, so it's going to be 8 back. So when you write these coordinates, just take note of comparing them to the original start of the pre-image and the image and see if you notice anything. And then when you try the next one that's like that, see if you notice any commonalities. So that's a reflection across the y-axis. And then you'd put those points. So -1, 2, -2, 5, -7, 0, and a -8, 3. Okay, so compare these to what these were and see if you notice anything about the points. That would help you shortcut maybe 3 and 4. Okay, so on the next page, you're finding still reflecting, but it's on across non-vertical or other vertical and horizontal lines, not the x and y axis. So I'm going to do 5. I already have something on that side of the paper. So 5, I'll do that one, and then I'm going to skip to the last set, which is, well, yeah. Okay, so 5. I'm going to throw these points on here. Go ahead and pause it. Throw the points on your graph. Okay, so this time that's our graph. We're going to be flipping it across the line x equals 4. So x equals 4 means we go 4 on the x-axis, and remember x equals 4 from the last unit is a vertical line. And we want to basically do the same thing that we did with the y-axis, but using this line now instead of the y-axis. So we figure out from this line, how far is L? It's 1 unit. So we want to go 1 unit the opposite direction. How far is J? J is 1, 2, 3 units. So we would go starting at the, so we want to start in line with J every time. We go 1, 2, 3 units, and J prime will be here, in line with K. So I'm always creating a perpendicular midpoint. So a perpendicular line through the midpoint. So through the middle of L and L prime, through the middle of J and J prime. So midpoint meaning, again, that there's the same amount of units on the right as there are on the left of the perpendicular line. Okay, so then my reflection would look something like that. So that's the reflection across y. Oops, across y equals x. Or sorry, x equals 4. Whew, it's getting. Okay. All right, so then that's most of the types. Then on the bottom you have some y equals x lines. So let's just recap, because even on the test this was popularly missed. Actually not so much by third period, but I think I did kind of introduce this one beforehand. So y equals x is in the form y equals mx plus b. If there's nothing written with after the x, then this is really understood to be plus 0. And then in front of the x is understood to be a 1, so the slope is 1, and it crosses at the y-axis at 0. This is not number 6, this is number 9. So if we graph this, and then you can just graph it on your own and pause it. Okay, so -5, -2. Okay, so these are the 3 points that we start with. And then the line of reflection this time, we have to be able to graph this line. So that's why the last unit is super important that you understood. So this line is crossing the y-axis at 0, and then it's rising 1 and running 1. And this line needs to be pretty accurate in order to do this using the graph. Like, you have to make your line pretty straight, or you're going to be off a little bit. So you can add some extra points that, again, follow the 1-to-1 slope. Rise 1, run 1. Okay, so that's my line of reflection. So again, I plotted the y-intercept, which was 0, understood to be 0, and then from there, this is a slope of 1/1, so I would rise 1, run 1, rise 1, run 1. Okay, so now what I'm going to do to make this easy on myself, because I need the line to be, I need to get to this line, but I can't travel diagonally, because if I do it over here, it's not going to be a flip across this line, it's really going to be a flip across this line. So I want to turn my paper so that this line, that is my line of reflection, looks to my eye set, that like a horizontal line. So I'm going to turn this paper like this, so that now this is parallel to my eyes. And instead of counting, so we still need to count from this, but we're going to be counting, we need a perpendicular line to this line. So our slope of this line was 1. So a perpendicular one is going to have a slope of 1, rise 1, run 1. So the boxes we're counting are still diagonal boxes. So, and this is a little confusing, but you're going to ignore all the other points and see from Z, how many diagonal boxes do you have to travel to get to the line of reflection at a right angle? Well, it's 1 diagonal box. So then we would go 1 diagonal box underneath the line of reflection, and that would be Z prime. Then for X, if I look at X only, I have to travel 1.5 boxes diagonally to get to the line of reflection. So then there's this half first, so that accounts for that half. and then one box, so this would be x prime. So it looks a little funny now, but it'll come together. Then y, I'm ignoring these points, and I'm going straight from y as quick as I can get to this, so I'm going one diagonal, two diagonals, 3.5. So I go a half, 1, 2, 3. So this would be my y prime. So from those, just like you did for the x-axis, you go straight down from where the figure's original coordinates were. And then you connect them, and those are your coordinates for the flip. So it'll look like it flipped over this line once I connect these. Okay, so now it looks like a flip across the, well, if I erase some of these pencil marks, it'll look more like that. Okay, so now it looks like the image flipped across this diagonal line. Okay. And then you'd write those coordinates in for the answer for number 9. Y equals negative x, so some of the equations are y equals negative x, is a slant this way. So it's very similar to this problem. Only difference is that you would be turning your paper counterclockwise instead of clockwise when you want to get it horizontal. Actually, it doesn't matter which way you turn it, but it's just that the line starts off going the other way. Okay, and then for the last part, you're just identifying where the middle of the corresponding points are. So like if you find a k and a k prime, find the middle of that, and then if you find the middle of 2 corresponding points, then draw a line through them. That'll tell you your line of reflection. So I'm not going to do that one because that one's a little bit easier. I'm going to do 14. So if I'm not sure where the line of reflection is, because these don't really look like a mirror image of each other from one of the main axes, I would find the middle of B and B prime. So it's about here is the middle of those. And then I would find maybe the middle of A and A prime is about, maybe C is a little easier. So C to C prime goes 5, 6, 7, 8, 9, 10, 11. I think it's 11, but I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So instead of going 11, I'll go 5.5. Because you go half the way. And then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, 5.5. So I'm going to go over 1, 2, 3, 4, 5.5. Go up 1, 2, 3, 4, 5.5. So C's midpoint is there. And I connect those 2 points, and that shows me that my line of reflection is the y equals negative x equation. So this part you're writing what the line of reflection is. That's it.